All right, so last week we did a whole bunch of things with data types. We first of all focused on integers, we talked about floats, we briefly touched on strings, lists, range, and Boolean. The reason why Boolean is in red is because we are going to be focusing on only Boolean for today. We also talked about different expressions and also what we could do with certain variables. So addition, subtraction, multiplication, the difference between true division and floor division, modulus, and powers. So we're going to be dealing with a little bit more of these. And finally, we talked about input and output. So how to print things and also how to get user input. How to convert what the user has input, because normally, remember, it was a string, but we were able to convert it into other data types so that we were able to be more flexible. We could do math with it. So this review question was supposed to get a gauge of how you guys felt about certain things. If this was too easy for you, that's good. If it was difficult for you, then you might want to practice a little bit more and go back to the review question. Like I said, if we have time, I would like to go back to this, but if we don't have time, we'll send out solutions for this, as well as programming assignment number 1, where you guys had to do the Mad Libs. All that being said, let's go into our topic for today, and that is Booleans. If you recall, Booleans are all about true and false. So capital letter T and capital, so true and false. If something is true, you want to follow a certain set of actions. Otherwise, so if something is false, you want to set of actions. Depending on the condition, you do something specific. This allows you to not have a one-dimensional program, because a one-dimensional program would just follow a structure, follow a sequence of steps, and that's it. But we know life always has more than one path. You have a decision to take path A, you have a decision to take path B, and that's exactly what coding could also lead to. You could take path A if the user does one thing, or take path B depending on the circumstances. So let's go into an example. Actually, not an example yet. We're going to talk about what was a Boolean again. So it's a data type used to define true or false. Remember to use capital letter T and to use capital letter F if you want to specifically talk about true versus false. If you use lowercase t or lowercase f, then you will get an error because it's expecting a variable. Now we're going to talk about conditionals and logic, and we're going to kind of do a few exercises. That way you guys can get into the mentality of how you should be thinking. This is what we call like a decision tree or a decision diagram. We start here. Should you study? Do you have an exam coming up? So if you do have an exam coming up, then you would follow this path right here, and then it says study. Okay, so you just study. But let's say you answer no. Then you would follow this right here, and then you would go into the next question so that you could figure out which path you need to take from there. Do you have homework to do? If it's a yes, then you should follow this path and then study. Otherwise, you go to the next set right here. Do you know what's going on in class? If it's a yes, then you can just relax. Otherwise, study. So notice like some vocabulary words that I continuously said. So like for example, I asked, if you have an exam, or do you have an exam coming up? And then I said, if you answered yes, then you follow this. Otherwise, or else, you follow this. Those keywords, if and else, are super important to pretty much every single coding language out there in the world, especially in Python. So if I were to take what we just did and split it up into what we call pseudocode. So let's actually just talk about what pseudocode is. Pseudocode is the logic of your code written out in code format, but not actual code. So you're not actually writing legitimate code like x is equal to this, or like having things in parentheses. You just want to explain what exactly is going on so that even someone who doesn't know how to program can look at it and understand what's going on. When we start here and go down, so that's when we start from the very top of the code, and look at, do you have an exam coming up? So if you do, so if yes, you do have an exam coming up, you follow this and you study, which follows this right here. If you have an exam coming up, study. Else, meaning otherwise, so if you don't have an exam coming up, that means you would follow this path. So else, and then after that you have this. Do you have homework to do? It's another condition, it's another question, another split in the path. Do you have homework to do? So if that is true, if yes, you do have homework to do, then you should study. Otherwise, so else, you follow this path because that's a no, that's the opposite. Else, and then you have yet again another question, like another split in the path. Do you know what's going on in class? So if you do, if you know what's going on in class, then you could relax. Otherwise, so going back here, otherwise, so that's the else, you want to study. Does that make sense to everyone so far? How we split up this code? So let's say I present this a little bit differently. So some of you guys might be asking, why didn't you just separate it into if and if? Like, why is there else's thrown in the mix? What happens if I get rid of the else's? So if we look at the next slide, we can see what happens if we do indeed get rid of the else's. Notice that the decision tree from before is completely different, right? So let's go ahead and follow this chain of logic and see how different it could be. Starting from up here, do you have an exam coming up? If that is true, so you follow this path, it will tell you to study. So if you have an exam coming up, then study. But notice there's no else. So what else does is it definitively divides the two paths. You either take one or the other. If there is no else, then your logic will work in a way so that instead of dividing the two paths permanently, they will reconvene, they will come back together. So notice here, because there's no else here, this path will converge with the no. It comes back together. There's no true division that will keep those two apart. Which means that they end up at the same place regardless. The only difference was that if that statement was true, you did have to visit the study. Let me use this color. You did have to visit study. If we keep going with this, so if you have an exam coming up, then you study. Otherwise, so there was no else, you just move on to the next step because code runs sequentially, one after the other. So you go to this one first, then you go to this one next, then you go to this one last, and then potentially you can come here. The reason why I'm saying potentially is because right here there's an else statement. So with this one, the division between the if and the else will be clear. There will be two completely different paths. This else statement also only belongs to the first if statement. This one, or sorry, not the first, the previous if statement. It'll belong to this one here. If and else's are always paired together. If, else. This if did not have an else following it. So that's the reason why this one is only an if. This one also, there is no else statement following it. So this one only has a lone if. The last if statement has an else following it. So this is where the paths will diverge. And we can see that happen right here. Do you know what's going on in class, which is this if statement right over here? There is, if it's true, then you want to relax, else study. Notice that these two do not go back together because we have an if and then an else. Comparing it with the other two, This one had just an if. This one also just had an if. So these two paths come together. Let's go ahead and still, I'm gonna erase everything and then go back to this. Let's go ahead and walk through this entire slide and see exactly how this logic will work. And I encourage you guys to just try this by yourself and also see if you should study or not. Sorry, I have to do this the hard way. I just have to undo every single mark I made because there's no eraser on here. Okay, perfect. So let's start here. Do you have an exam coming up? So for me personally, I do have an exam coming up. So I'm going to follow this and then it's going to tell me to study. Then after that, I just continue to follow the course of the decision tree. The decision tree isn't over. Study is not a dead end, so I just have to keep going. So all I've literally done so far is, if you have an exam come up, study. Now we're at the next part of the decision tree because my code is sequential. Do you have homework to do? So personally, no, I don't have homework to do. So I'm just gonna go straight on. So because this is false, I ignore this. I ignore that study because if you have homework to do is, in my case, false. So it's like if you just think about it in English. If you work hard, then you will get a 5. So if you work hard, if that is a true statement, then the conclusion after it, you will get a 5, should be the part of the code that is run. But if you don't work hard, so let's say if you work, like the first hypothesis, if you work hard, that's false, then you should not expect your conclusion to be true. That means you have to move on to something else, either an else statement or just completely skip the statement altogether. So do you have homework to do? I don't, so I just move on. Do you know what's going on in class? So I do know what's going on in class, then it tells me to relax. So this right here, I would not recommend this kind of code because this is pretty contradictory. It's telling me to study and it's telling me to relax. So that's the reason why you need to really think about your logic, think about where the if statements go, think about if you need an else statement, or if you need like an if or an else if statement. So we're going to talk about all of these different aspects today. This is just an introduction. If you're feeling lost right now, don't worry. We're going to be doing a whole bunch of examples, fleshing out as many as you can, and hopefully by the end of this you will feel better. Depending on how today's lesson go, it may be split up into 2 parts actually, because conditional logic is going to be the basis for many different things that we're going to be doing here. Let's actually do some examples first. So I'm going to share a different screen at this point. So if you want to follow along, feel free to do so. I'm going to be just working out a couple of things. That way you guys can see some really nice examples. Let's say we have x is equal to 3. The code I want to write is going to be check if x is positive or negative. So anyone tell me, how do you know if a number is positive? What is the definition of a positive number? Number that is greater than 0. So this is where your math will come in. You should know all of the symbols, greater than and less than, right? Greater than and less than. But when it comes to Python, how would you denote greater than or equal to? This is greater than or equal to. We have less than or equal to as well. So I'm going to actually just label it line by line. So this is greater than. This right here is less than. This right here is greater than or equal to. And this one right here is less than or equal to. When you write out your conditions, you should be writing it as if you're just talking in English, but also using mathematical syntax. Check if x is positive or negative. You guys said a positive number is something that is greater than 0. So if my value x is greater than 0, then we will print positive. How do we know something is negative then? How do you know if x is negative? If it's less than 0, good. So if x is less than 0, then you want to print negative. Let's test what we have so far. So I'm gonna run this. This is not the right file, Python. So we can see that here it prints out positive. Positive has been printed out. Because x is 3, 3 is greater than 0, it'll print out positive. X is not less than 0. So this statement is false. So it will ignore this right here. Let's talk about some vocabulary. So we've just talked about what we did. Let's talk about some vocabulary. Whenever you start a condition, always open it with an if, and then in here we'll go the condition. What you want to evaluate is true or false. In the case that condition is true, then it will go into the index, or sorry, into the body of the if statement. This stuff, the body of the if statement, will run only if that condition is true. If the condition is false, it'll completely skip that body of the if statement. So there's no in between. There's never like a maybe this is true or maybe this is false. It's either true or false. And then if it's true, you go in the body of the if statement, do whatever you need to. If it's false, it'll move on. You indicate the body of the if statement through tabs. So through indentation. Everything that this is also part of the body. Everything that is indented over is considered part of the body of the if statement. So everything that is tabs over 1 is going to execute in the case x is greater than 0. So if I decide to print here, positive and yay will both print out because of the fact that it is inside of the body. It's indented over, it's perfectly aligned with everything else that is supposed to print out, or that is supposed to be executed in the case x is greater than 0. So let's go ahead and test this out. What if x is instead of 3, x is negative 3? What should print out then? What should print out if x is negative 3? Perfect, it should print out negative, right? So we can see negative has been printed out here because when we follow this, x is currently negative 3. We go into this statement right here. If x is greater than 0, x is not greater than 0 because x is smaller. So instead what happens, it'll go into here. If x is less than 0. Negative 3 is less than 0, so it'll print out negative. And that's the reason why negative has been printed out right here. What if, though, I change the x from -3, it is now 0? What will print? Right, nothing is going to print. Notice that after I ran this, nothing has come out. Let's take a look at y. X is equal to 0. If x is greater than 0, 0 is not greater than 0. So it's going to completely skip this right here, the body. And then it goes into this one. X is less than 0. So if we try to check like 0 less than 0, that is also false. So it'll completely skip this. Everything has been skipped. There's no actual instructions that have been run. That's the reason why nothing has printed out here. What if I decide to put here else print 0? Is this correct? Would this work? Like, is this a completely flawless program? Like that will work for every single test case that I were to try? No, right? So it looks like, in the surface, it looks like it could possibly work. And it does work for 0. If I try to run this, I do get 0. But let's say I try to run something else. Let's say I go back to my example 3. X is equal to 3. I'm getting positive and yay, which is correct, but I'm also getting 0 printed out as well. This is the flaw in the logic. Let's run through this code step by step and see where we could have possibly gone wrong. So I do have to draw with my mouse here, so it might look a little weird. I apologize in advance. We have x is equal to 3, and we start with this statement right here. If x is greater than 0, so 3 is currently our x value. If 3 is greater than 0, which it is, we should print out positive, and we will also print out yay. We're doing good so far. If x is less than 0, well, 3 is not less than 0, so it'll skip this part, and then it sees, oh, else. Remember, if and else is where the two paths diverge. You either take one or the other. So if x is less than 0, we can't take that path because it's false. 0 or 3 is not less than 0. So we must take this path, and that's the reason why 0 prints out. So not perfectly flawless code that we have here. What we need instead is what we call an else if. And to write else if, you use ELIF. ELIF is the same as else if. So if I were to, I guess, draw a representation of what is going on here, we first want to check if x is greater than 0. If it is, so yes, I'm going to put a check mark for yes because I can't write right now. If it is, then we know it's positive. Else if, meaning the paths diverge and they should not come back together, we check if x is less than 0. So else if right here, that means this is false. X is less than 0. We have another divergence right here. Because if x is less than 0, so this is true, then that means it's a negative number. Else, so otherwise, it's 0. Had I not included this L for the else if, my path would have looked different. So let's explore that one. X is greater than 0. In the case it's true, maybe I should have put T, now I'm thinking about it, instead of a check mark. So I'm gonna put T's now. So in the case that it's true, then it must be a positive number. There's no else. So what happens is that if this is false, regardless, these two paths will reconvene. They will meet each other again, and then you have to check if x is less than 0. And in the case if it's less than 0, you will, if that's true, that will be a negative number. Otherwise, if it's false, that means it's a 0. The two paths here are very, very different, especially because one will reconvene. And now you run the risk of classifying a number as two different types, positive and 0. So now I'm going to clear everything, and let's go ahead and try everything all over again. Now if I try 3 prints positive and yay. If I try -3, or I guess -2 just happens to be what I typed, it'll print out just negative, so we're doing good so far. And if I try to run 0, this will give me just 0. So the difference between if, elif, and else are going to play a pretty big role. Don't worry if you're still a little bit hesitant about how everything is going so far. We do have some more practice coming up. Let's go back to the slides. Okay. We talked about the difference between them. We might have talked about some things right here. All right, comparison and logical operators. I'm actually going to skip the slide for now. I'll revisit it because I want to talk about what we just did, actually. So conditions result from comparisons. We saw that before. We used some of these already. We use the greater than, we use a less than. We did not use greater than or equal to or less than or equal to, but you could potentially use it, especially if you really need to use this symbol right here. Oopsies. This symbol right here and this symbol right here. So if you remember this in math, these are exactly the same symbols. It's just that there's no easy way to write that symbol in Python because I don't think there's like a keyboard, I don't know the keyboard shortcut for this. So you use greater than or equal to or less than or equal to. The two I want to bring your attention to now are going to be the equal to. So the difference between just an equal sign and an equal sign. This one right here we've used a lot already. We used it for assignment. When we assign a certain value to a variable, we always use a single equal sign. When you want to compare, however, make sure you use the double equal sign. That way it knows the difference. Comparing two numbers, making sure that the left-hand side and the right-hand side are equal to each other. Is 3 equal to 3 or is 5 equal to 5? Then you want to use the equal to. But if I say I have a variable x and I want the value 10 to be set to x, so x is equal to 10, you want to use a single equal sign for that. And then for this one right here, the one with the exclamation mark in front of the equal sign, this is not equal to. So our two values differ from each other. Is 5 not equal to 5? That would be false because they're actually equal to each other. So we're going to do a couple of these in further detail. We're going to use these, including the operators and like the operations that we talked about last week, to test how much you guys have figured out about Python so far. So tell me, if a is equal to 3, and we have a modulus 3 equal 0, print factor, else print not a factor. What would print here? It would print out factors. So I hope you guys remember that this symbol right here, modulus, just means the remainder. So if you do a modulus 3, this would be 300 modulus 3. 300 divided by 3, and then we get a specific remainder. So if you do 300 divided by 3, you get 100 with a remainder of 0. So this is a true statement because the remainder is 0. 0 is equal to 0. Okay? So this is a true statement because we're doing a comparison. Notice we're using 2 equal signs, not 1 equal sign, because if we were to use 1 equal sign, then that would be an assignment operator, and that would give you an error because you're trying to assign a value to an expression. So the correct answer for this one was factor. Next one, a little bit more going on here. X is equal to 3, y is equal to 10, z is equal to 36. If x times z is greater than z, print product bigger, else print product smaller. What would print out in this case? Good, product smaller. So we have x is 3, and then we have y, oops, not that color. We have y is 10, and finally we have z is 36. So plugging these all in, we just want to double check if this is a true statement. If it's a true statement, we will print out product bigger. Otherwise, we'll print out product smaller. So 3 times 10 is greater than 36. 3 times 10, however, is going to be 30. And when we look at 30 is greater than 36, this is a false statement. It's a false statement, so we do not go into the body of the if statement. Rather, we care about what's inside of the else statement. So we look here and it says print product smaller. So that's the reason why product smaller will print. Next, we have this one right here. Num1 is equal to 6, num2 is equal to 7. If num1, remember the double division sign is floor division. So you divide it, even if you get a decimal, you round down. So if num1, floor division, num2 is less than or equal to 0, print non-positive. Else, print positive. So what will print out here? Very good, non-positive. So taking a look, num1 is 6, num2 is 7. So when we do 6, floor division, 7, and we compare it with 0, so I'm using the greater than or equal to sign, like the one that you guys normally use in math. That's the same exact thing as this one here, just a little reminder. 6, floor division 7. So normally 6 divided by 7, you would get like 0 point something. But regardless, because this is floor division, you always round down, and that's why we get 0 is less than or equal to 0. So 0 is less than or equal to 0 is true. 0 is equal to 0, so it will print out non-positive. And then it ignores the else statement because the else is where you go to if the condition, the original condition is false. But this condition is true, so we just move on. The conjunctions that you can use here are and, or, and not. So most of the time when you try to show something, you might not necessarily just use one condition. You could have multiple conditions. Sometimes you want both of them to be true. Sometimes you only need one of them to be true. Sometimes you need something to be false as well. So that's where and, or, and not will come in. So if I said, for example, if you are in high school and this is your first year, then you are a freshman. Both of these things must be true in order for you to be considered a freshman. So if you are in high school. If that is false, already you cannot be considered a freshman. And then the second condition I gave was if you are in your first year. So if you're in high school, but you're not in your first year, that means you are not a freshman. So you need this right here to be true if you're in high school. And the second part, if you are in your first year, that is true, then this entire statement would be true. If one is false, then neither of them are false. But let's say, for example, for an or. Or means that one of the statements to be true. Let's change this must to needs to be. So if I said, as an example, if you are a junior or you are a sophomore, then you can take the PSAT. So you could be a junior and not be a sophomore, and this statement will still be true. Then you could take the PSAT. You could be a sophomore and not a junior, and you can still take the PSAT. However, if you're neither a junior or a sophomore, then that secondary follow-up statement is going to be false. And finally, we have not. So not means the inverse of whatever you have. So if, for example, if you are not fond of dogs, then you're not here. I can't think of something. So if you are fond of dogs, that would normally be what your condition is, but not will invert it into the opposite. So that's exactly what's going on here. Not just means the inverse of whatever you previously had. Okay, we are probably not going to finish this today. So what I'm going to do actually instead, we're going to revisit and or not because we only have 10 minutes left. We'll revisit it next week. Instead, we're going to focus on the things that we've already done with the greater than, less than, greater than or equal to, less than or equal to. That way you guys could feel comfortable with that, and then we can move on, review next week, and move on next week as well. So ignore this stuff for now. I'm going to go back to up here. And let's do a quick exercise where we are going to discuss grades. So normally when you have a 98% to a 100%, that's an A+. If you have between like a 90, let's say 90, 92% to a 97.99999%, that would be an A. And then if you had between a 90% through a 91.99999%, that would be considered an A-. You guys are familiar with this grading scale, right? So what we're going to do is ask for user input, see what the grade is in for a class, and then print out what their grade would be considering their, or like print out the letter grade considering their score. If I were to just do one more line, just so we could be completely clear, it's 88% up until an 89.9999% would be considered a B+. There's more than one way to attack this. We are going to do this without the use of conjunctions, so without the uses of ands or ors, without any of that. The reason why is because, yes, you could take this approach that we did right here, the thing I'm highlighting. You could do like between a certain set of numbers and then print out accordingly. But there is another way you could do it using just ifs and elses. And let's go ahead and tackle this right now. We first off need an input from the user. So grade is equal to, we want this to float. because grades aren't always going to be whole numbers, we're going to have a float that will represent the grade itself. So floats, input, what's a grade? Now what is your grade in percentage? So when you ask that, it'll just ask for the grade. You type in a percent, and now with the grade, we can do a whole bunch of, we can figure out what to do. So let's start with the A+. The A+ is going to be between a 98% and 100%. Anything more than a 98%, pretty much. So anything, because technically you could get over 100% if you have extra credit. So if you have over a 98%, then it should be an A+. So exactly what I said. If the grade is over a 98%, so at least a 98%, meaning greater than or equal to 98. Because 98 is included right here. So if the grade is greater than or equal to 98, then we want to print out A+. Otherwise, we want to check if it's greater than 92 instead. So notice I said otherwise. Otherwise means is equivalent to else. So else, we want to check if the grade is larger than 92. That will call for an else if. So else if the grade is larger than or greater than or equal to 92, then we would print out an A. Now you might be asking, like, does this work? Like, I'm not including the ranges. I'm not including from between 98 to 100, 97.9999. Like, none of that is being completely clarified in this case. Would this work? So if it does work actually, because I have the if statement, if grade is greater than or equal to 98, and then we have the else. The two paths will diverge from each other. So if it is indeed greater than 98, then it'll print out A+ and skip the rest of the statements. We skip everything else that we have because we have found the condition that is true. However, in the case the grade is not greater than or equal to 98, so that would be a false statement, it'll go into the following and then check if it's greater than or equal to 92. It has already, it already understands that it is not greater than or equal to 98. So we have eliminated that prospect. The next choice is an A- to check if we have an A-. So L if the grade, well, it has to be greater than or equal to 90 in order for it to count as an A-. So greater than or equal to 90. And then we could print the A-. Let's just test what we have for now, and then just make sure that everything is working. We're going to test 4 different things. What happens if it's over 98%? What happens if it's in between 92 and 98? And finally, what happens if it's between 90 and 92? That was 3. We're going to test another one that is less than 90 as well, just to see what we get. So the first time I run this, it asks me what is the grade. So I'm going to say 99%. We should expect an A+ to print out, and indeed the A+ does print out right here. If we test a smaller number, in between 92 and 98, we should expect a A to print out. And we have the A print out. And if we test something that is between 90 and 92, let's say 91, let's be bold, 91.999999999. So it's not quite 92, A- should still print out, and we get the A-. So we're doing good so far. And finally, if I try to do something that is less than 90, we don't have anything for it yet. So if it's less than 90, nothing should print out. So if I try 89.999999, nothing has printed, or nothing in the code tells Python exactly what to do in the case it's less than 90. So nothing is going to print out, and that's exactly what happened. So we're doing great so far. What if, so now we have to do the B plus. B plus is between 88% and then 90% not inclusive. So including the 88% still, so greater than or equal to 88, we would print out B plus in quotation marks. And then for the B, it has to be greater than or equal to 92. So elif grade is greater than or equal to, 82. Then you print out B. Otherwise, if it's greater than or equal to 80, it should print out B minus. So again, let's go ahead and test what we have so far just to make sure that everything is going okay. Once again, we were able to do this without any conjunctions, without and, or not. So, there is more than one way to implement this. It would be, if you guys think you have a different way, feel free to do so. And I'm not giving out a programming assignment today. I probably will send out a homework. So let's try, what if I had 88 exactly? So because 88 is equal to this condition right here, so 88 is greater than or equal to 88, we should still expect a B plus. So B plus prints out. If I tried to do it again with an 85, we should see B print out, and that's exactly what we get. And then if I try 80.00000001, a B minus should still print out because it is greater than or equal to 80. If I try 79.9999999, because we don't have a condition yet that deals with it, we don't have anything print out. So let's keep going. We're almost there. We have a minute left, so we're just gonna power through this. Greater than or equal to 78. We're gonna print out a C plus. elif grade. Oh, I just really want to copy and paste everything now. 72 would print out a C minus. Oh, sorry, just a C. elif the grade is greater than or equal to 70, we would print out a C minus. elif the grade is greater than or equal to a 68, you're going to print out a D plus. elif the grade is greater than or equal to 62, you're going to print out a D. elif the grade is greater than or equal to 60, you're going to print out a D minus. Now, we are going to top this all off with just an else statement. Print F. So the reason why we're going to just print out F here is because we've traveled through all of the elif statements, and if not a single one of them are true, it's not an A plus, it's not an A, it's not an A minus, it's not a B plus, it's not any of the C's, it's not any of the D's, it must be an F. So you failed all of the test cases, come down to the very last one. If it's not any of the previous ones, it must be an F. So let's go ahead and just test this one more time, and then we're going to go, we'll be done. So what is your grade? Actually, we can test it twice. We're going to do like a random one, 64. We should expect D to print out because it's in between. Right here, if you look, it's greater than or equal to 62, but it has failed all of these prior ones, so it's going to print out D. Now, if I try it again, but with 45%, we get an F because it is not greater than or equal to 60, and it's definitely not greater than or equal to any ones prior, so we just print out F because that is the final else statement. All right, that is going to be it for today. I will upload the video later on, or probably hopefully by the end of today. If you guys want to take a look at it, I will also send you guys this file if you want to take a look at it as well. If you have any other questions, I'll be around for a little bit longer. Other than that, I will see you guys next week.